All right, so we'll start today with the determinant of a 2 by 2 matrix, and we're going to be using this guy's formula. His name is Leibniz. Okay, and his formula goes something like this. All right, so the entries are for the matrix. It's A1, B1, A2, B2. Okay, and I was just thinking, sometimes, okay, this is just my notation, but sometimes you'll see it like this: A11, A12, A21, and A22, right? Or X, or whatever. But the 1, okay, that's not 11 and 12, but that's row 1, column 1. And A12 means row 1, column 2. A21 means row 2, column 1, and A22 means row 2, column 2, right? But for today's sake, we'll just keep it simple, and because we're not doing all of that just yet. We're just learning the basic formula for Leibniz's formula, okay, for the determinant. And the rule goes something like this. Okay? If you don't find the determinant of A, okay, you can write it as DET A, okay, and that stands for determinant. Right? So you can write it as determinant A, or you can write it as kind of like an absolute value. Okay, so there's two ways to write the determinant. Okay, so you can either write DET for determinant of A, or you could just put A in the absolute value, and that looks like an absolute value of A, but it really means the determinant of A. Okay? Or you can write it as the absolute value, right? But remember, it means determinant. Okay, but you can put actually the matrix in there. So kind of like the absolute value bars, and then A1, B1, A2, B2, right? And this isn't the formula yet. This is just the different ways that you can say the name determinant of A. Okay, kind of like Alex, right? There's different ways to say Alex. You can say Alex, or Alejandro, or A, or Big Daddy. I mean, there's a lot of different ways you can say Alex. Okay, so different ways to say determinant of A. You can actually say determinant of A. You can actually say the absolute value of A, which is really means, and you're not going to say absolute value. You're just going to say determinant of A. So you can say it this way. You can say determinant of A. You can say determinant of A, or you can say determinant of A. Okay, it doesn't matter which way you say it, but they all mean determinant of A. Okay. Enough chatting, right? But how do you find the determinant of A? Okay, so first you're going to have to do A1 times B2. So this is the actual formula. Okay, this is Leibniz's formula. Right, so the formula says you take A1 and you're going to multiply it with B2. So you're basically just kind of taking care of that diagonal. And then you're going to do a subtraction. Okay, yes, it's always subtraction. Even if the number behind it comes out to be negative, you're still doing subtraction. Yeah, in that case, you'll be doing addition, right? So it's double subtract. Right, and then you're going to do A2 times B1. So you're going to do the other diagonal. Right? That's pretty much it. For 2 by 2, it's really simple. Yeah, let's do one example. Let's look at here with actual numbers, right? Well, a couple examples. So let's go. Okay, let's go. Matrix C equals 1, 5, -2, 6. Right? I'm out of ideas today, guys. I'm just making it very simple. Okay. So we can say determinant of matrix C is equal to. Okay, and the rule says I'm just going to multiply the diagonal. So you got to do the downwards diagonal first, guys. And when I say downwards, I mean from, if you're starting with your left side, because that's what we do here in America. We start writing on our left side. Right? You always go do the down diagonal first. So it's a 1 times the 6. Okay. You're going to go 1 times 6. And then you always do a minus, like I mentioned. Okay. And then secondly, you do a up diagonal. And again, from the left-hand side, which diagonal goes up? What's the one that starts from the bottom? Okay. So the up diagonal is second. So negative 2 times 5. Okay. Okay. So the determinant of C is 6 minus negative 10. All right. Notice how I didn't just say 6 minus 10. Okay, it's 6 minus, because that minus is always there. And then if you get negative 10, you get to put negative 10 still. Okay, don't just say, well, it's already minus, I don't have to put a negative. No, that would be wrong. Okay, so 6 minus negative 10, that's actually 6 plus 10, which is actually 16. Okay, the determinant is 16. And this is actually faster for a 2 by 2 matrix. This is actually faster than doing it on a calculator. Okay. Calculator, you actually have to type in those numbers. You have to type in the matrix. And I don't mean like a regular calculator. I mean a matrix calculator. Okay. Let's do one more. Okay. Example. Okay, let's go matrix X. Okay. Matrix X equals 5, 4, 3, negative 2. Okay. Again, like I said, I'm not really feeling adventurous or exciting today, so not thinking much. Right? So another way to write a matrix, you can write it as this. Another way to write the determinant is you can just write it like the absolute value bar. Okay, but we still say determinant. Okay, so determinant of X is equal to 5 times negative 2 minus 3 times 4. Okay, what's the determinant of matrix X? Let's go with Rachel. Rachel, what's the determinant of matrix X?
Is it negative 22?
It is negative 22. Good job. All right. So 2 by 2 matrices, determinants, using Leibniz's formula, really easy. But it's not going to be as it's not going to be as fun as the next one. Next one will be easy, but it'll be just as fun. Okay, kind of like that. And remember, okay, with this method, you're doing the down diagonals first. Okay, and you're multiplying them, and then you subtract the up diagonal second. Okay, so it's going to be these two. So it's going to be this diagonal firstly, minus, and then you're going to do this diagonal secondly. Okay. All right. So this is called. So the next one we have a 3 by 3 matrix. Okay, remember they have to be squares. Okay. So we're going to find the determinant of matrix B, and this is a 3 by 3 matrix. Okay. This method is called the rule of Saurus. Okay. No, it's not related to SARS, or it's not a dinosaur. Okay, it's just called the rule of Saurus. Okay. It's a guy. It's his last name. Right. So if you created something that the world is going to use, You can name it whatever you want. Most people, that's the way that they become immortal. That's the way that they like to live on forever, and that's through what everyone remembers them by, and that's that. Okay. Okay. So the rule of Cyrus, right? I'll show you in a bit, but matrix B, let's label it as top row A1, B1, C1 for row 1. Middle row, second row is A2, B2, C2, and third row is A3, B3, C3. Okay. So go ahead and kind of jot those down. You don't really need to look at this because I mean it goes A, B, C, and then it's just one, 2, and 3 depending on the rows. Right? But I'm actually going to jump to my to this because it's kind of hard to write on my PowerPoint. So I'm going to go ahead and just kind of shut that down for now. Judy, Ollie.
Yeah, I know.
Okay. So, all right. So, the rule of Cyrus goes something like this. Okay. So what we're gonna do is we're gonna copy down, and the awesome thing is you can go in any direction, right? So, yeah. I mean, so the idea is that this matrix it wraps around like the Earth, like a circle, right? If you take this matrix flat and you roll it around, right, it makes kind of like a tube, right? So if you go A1, B1, C1, okay, the next number is actually A1. It kind of goes around the circle. Does that kind of make sense? And the next number is B1 again. Okay, and we're only going to use two. Okay, so A2, B2, C2, and then we're going to go A2 again and B2. Okay, so really, guys, all we're doing is just copying down these two rows. And we're going to just copy it and we're going to put it right here. Okay, so I mean, that's, if you just want to memorize that or just want to know that, that's all we're doing. Okay, so A3 and B3. Okay, any questions so far? Okay, so we're just copying down the first two columns. Okay, so the rule of Cyrus goes something like this, right? So the determinant of B is equal to, I'm gonna write this kind of small because it's kind of takes a little bit of space. So you guys remember how I mentioned using Leibniz's formula, you're going to do the down diagonals first. So there's only three down diagonals here. If you think about it, you get A1 times B2 times C3. Okay, so you're going to multiply those numbers. Okay, so you're going to go A1 times B2 times C3. Okay, and then we're going to add. And then we're going to do the other diagonal, other down diagonal, because there's another down diagonal right here. It's that B2, C2, A3. B2 times C2 times A3 plus, and there's one more down diagonal right here. Is that C1 times A2 times B3. Whew. That's all the down diagonal that we have. Okay. So all that, you got to figure out what that number is, or what that answer is. So those are the down diagonals. and then you're going to go minus. Now we're going to do the up diagonals. Okay. So what up diagonals? Well, this one here. Okay. A3, B2, C1. Sorry, that's my ring. All right, so you're going to go A2, no, sorry, A3 times B2 times C1. You get that answer in, plus, and then you can do the other up diagonal. B3 times C2 times A1. Okay, take your time on it. I'm writing a little smaller, so yeah, just you have to listen to what I'm saying if you can't read it. And then plus the last up diagonal, C3 times B times A2 times B1. Okay, so add those together, because those are going to be added and come together, and then subtract the two. Right, again, this is a rule of sorrows. Okay, the A1, B2, C3 plus, okay, all that, it doesn't really matter, okay, guys. It only matters that you're doing the diagonals. You're multiplying the three numbers in the diagonal together, plus the three numbers in the other diagonal together, plus the three numbers in the next diagonal together, okay? Or, let's hold that thought for a second. You can do it with the columns. So for example, if I got A1, B1, C1, A2, B2, C2, A3, B3, C3, you can add in more to the column. So you can add the top row. You can do A1, B1, C1. See how we go from 1 to 2 to 3, and then now I'm going to jump back to 1. Then the next row, A2, B2, C2. Okay? And again, I'm only doing 2x1 because what I need is I need to have the down diagonals. Okay, so that one makes a down diagonal. Then see, by doing that, I get one more down diagonal, and then by doing that, I get one more down diagonal. Okay, so you can do all the down diagonals minus all the up diagonals. If you look at it, okay, the up diagonal, and up diagonal. Okay, getting a little sloppy, but giving you guys an idea. Okay. Okay, but we'll stick to the basic, and just like how I had it originally. Okay. And like I said, like I was mentioning earlier, in reality, it's really A1, B2, C3, right? And then the next one is going to be, so it looks like this, guys: B1, C2, right? And you kind of, you guys, this is the way I kind of think of it. You guys know, like on the barber shop, you guys see that the little thing on the outside of the barber shop, like the little thing that kind of spins around. Who's seen that before? Yeah, right. Right. So this wraps around. So B1, C2, it wraps around to A3. It actually does this. Okay. Really, we're just writing the two columns down just to help us, but really that's what's happening. If it was spinning around, it'll be B1, C2, and the A3 wraps around the other side. This is what's cool about math. And then C1 is kind of all by itself, but really, right, it wraps around to A2 and B3. Okay. So if that kind of makes sense to you, I mean, you can do that instead of writing the two columns. Okay, but then it does get a little confusing. So so it's just a lot easier for everyone just to write the columns. Okay. So that's how you would do the determinant. And again, guys, it's the same setup as the last one. Okay, it's the down diagonals minus, and then this is the up diagonals. Okay, just like how we did the last one, just like how we did with Leibniz's method, right? It's the, see, A1, B2, this is the down diagonal. Minus, and this is the up diagonal. And because we're just doing A1, B2, down diagonal minus A2, B1, up diagonal. Right. But let's do a little practice, okay? So this just give me a heads up. There's different ways to do determinants, okay? But I chose the two that would be fastest for us, easiest, so that we wouldn't be totally confused, and that they looked exactly the same, okay? Although they're called by different names, okay? So for 2 by 2, the down diagonal minus up diagonal, that's was originally discovered by Leibniz, and then the 3 by 3, basically you're working with the diagonals again, okay? But this one's called the rule of Saris because it's, I don't know. Okay, so let's do a quick practice, right? And then we'll call it a wrap. We got 11 minutes, so that's plenty of time. Let's do it. Let's use the rule of Saris for this 3 by 3 determinant. Okay, so I'm going to go ahead and say determinant of A. And actually, and if you guys ask me what I prefer to write for determinant, I can write DT. Okay, instead of the absolute value bar, or instead of, yeah. So, okay. So again, you can do it any way. You can do it with the columns or the rows, or heck, you can even do it with in front of it or above it, as long as you have down diagonals and as long as you have up diagonals. Okay, but I'm going to go ahead and copy the first two columns down. So -2, 7, 6, and 9, -6, and 7. Okay, so you guys are going to be doing down diagonals. So go ahead and figure those out. So this multiplied together plus this multiplied together plus this multiplied together. Go ahead and do that. So what do you get for that answer? Right? And if you need to use a calculator, use a calculator. Okay? There's no shame in that. Just right now we're just after the answer. So some of these numbers are kind of big. Any volunteer for the first one? What's your total for the first one? For the down diagonals. And zeros are easy, right? Because anytime you see 0, that whole row gets knocked out. Because when you go 0 times anything in that row, it just turns to 0. And then if you add it, you're adding 0. So it doesn't change. It doesn't change the value of the other diagonal.
Correct me if I'm wrong, but is it 124?
You are right. Good job. Yep, it is 124. Yep. So the first row came out to be negative 72. This one came out to be 0, right? And you're adding them, so it stays negative 72. And this last one came out to be 196. So basically, you're doing 196 take away 72 because you're adding it, so it's just going to subtract. So Julian, you are correct. 124. Okay. And then you're going to go subtraction, right? Because it's always going to be subtraction in the middle. And then now you're going to do the up diagonal. So you're going to go 6 times negative 6 times 4. Okay. And then multiply those and then add it to 70 negative 2. And then add it to 679, right? And those would be the up diagonals. Again, zeros are easy. Zero just means you don't even have to look at that row or that diagonal. Okay, anybody get the green one yet? Get the up diagonals yet?
I got negative 5. Oh, I got negative 522.
All right, Emma, you are correct. Now, negative 522. Now you see that it has a minus negative 522, right? So I'm glad, Emma, you mentioned that it is negative, right? Yeah, because I mean, just because it's minus and then you have a negative 522 doesn't mean that the negative is taken care of. The negative is still there. Yeah. So the math is actually 124 plus 522, right? Or the total is what? 646. Okay, so the B determinant is 646. Okay, check your math. Just be careful with it. Okay, but to me, this is the most straightforward way of doing it. Yeah, we got 4 minutes to spare. Any questions on this? Okay, your homework tonight, and I haven't posted it up yet. Determinants of 2 by 2 and 3 by 3. Okay. All right, any questions on anything before I let you guys go? I know I usually go over time. Today, I can be proud to say that I am letting you guys go right on time. There. My point due tomorrow by 11:59. That's on topic 7. Okay.
I say for Christmas, we all get 100% on homework.
If you finish with this, yeah, totally. Right? All right, so basically you have some practice with 2 by 2s. Should go by like this. And then you got a couple practice with 3 by 3s. Okay. Last one's kind of like a little trick question, but I think you guys can figure it out. If you write out the whole thing on the very last one, number 16. Okay. All right, guys.
Charles, is this our last homework assignment?
You may have one more tomorrow about applications like, hey, when do we use determinant, or like why do we need to learn it? Okay, so I might have an assignment on determinants and applications of determinants tomorrow. And it should be pretty straightforward. All you're doing is just determinants. Okay. So I believe, Trevor, there should be one more, and then that's the last one. So Wednesday will be the last day that I'll give you assignment on anything. Okay, and your final will be Friday. I'm gonna make it really quick and fast. It's just gonna be over this chapter, and it's I'm it doesn't have to be 500 questions or 75 questions or you know 27 questions. It could be small. Okay? I just have to give you something just so that I can say, hey, I gave you a final. Okay. So, all right, guys. But we'll call it a day. Homework is up already. You need help on anything? I'll be here for another 22 minutes. Okay. And then you always have my office hours today as well. All right. Peace.
See you, John.
Bye, guys.
All right, John, appreciate it.
Yeah.
See you tomorrow.
Yeah.
Mr. John, I had a question on last night's homework.
Oh, yes. Oh, you know what? I should stop the recording.